Good morning. Today, this is going to be our last two videos on polyatomic ions. Yesterday, we learned what to do when we had to crisscross down to a monoatomic. And I emailed out my mistake, and my mistake came on example 3. So to put a little 3 there. Okay. All right. So far with polyatomics, we've canceled and we've crisscrossed, but everything we've crisscrossed to has been to a monoatomic ion. So what happens if we have to put a polyatomic ion in parentheses? Okay. So today's lesson title, we're going to call this Crisscross with Polys. Today is the 50th anniversary of Earth Day. All right. So here's an example, and I'll let you guys pause the video after I write it, so you can kind of maybe try it on your own. Example 1, let's do calcium nitrate. Okay, so take a moment, pause the video and find both calcium and nitrate. Okay, calcium is in group 2, so its charge is 2+. Nitrate, from your polyatomic ion chart, nitrate, be careful, it's this NO3. Make sure you're paying attention to the endings. All right, so it's NO3, and it's in the 1- category. Okay, look at the charges. We have a 2 and a 1. Do they cancel? No. So take a moment, pause the video, and see if you can figure out how to write it. All right, the common mistake that most students make is that they try to, remember, we never crisscross this 1, so this is not going anywhere. But they know that this 2 has to get crisscrossed down. So some common wrong answers, are Ca and O6. Some students are like, okay, well, I'll multiply. 2 times 3, bam, there we go. And some students might write CaNO5. That's also wrong. They got it. They're like, okay, I'm going to add 2 plus 3, and I'm going to get 5. Both of those are wrong answers. And the reason that they are wrong answers is that NO6 and NO5 are not nitrate. Nitrate is NO3. And we've said before that you can never change that number. If we were in class, you would see me using hand gestures to kind of explain this. In math, how do you indicate that you want to take this quantity 2 times? So I want this whole quantity times 2. All right, so if you can imagine the hand motions I'm making a set of parentheses. So it becomes Ca parentheses. Put nitrate here in the middle. Close your parentheses. And now what is gotten crisscrossed comes down here. So what you're essentially saying is you're saying, I'm taking this nitrate ion 2 times. Okay, so how does that work out in the grand scheme of things? Well, I'm taking calcium once. Remember, there's the subscript there. And it has a charge of 2+. And how many times am I taking this nitrate? Well, I'm taking this nitrate 2 times. So -1, that gives me -2, and -2 cancels out with the +2. So the take-home message, or what we normally write to help us understand this, is polys get parentheses when crisscrossed. So if you're looking at something from this chart and you have to give it a subscript, it has to go in parentheses. Okay, so polys get parentheses. All right, so let's do another example. Maybe we have something like calcium. Oh, we already did calcium. Let's do magnesium chlorite. Magnesium chlorite. Okay, if you want to pause the video and try it on your own, go right ahead. If not, just I'll explain it. So magnesium is in group 2, so its charge is 2 plus. So what does it have? I have an ite, so that clues me into that I need to look at my poly chart. And here is chlorite. Be careful because there's a hypochlorite, a chlorite, a chlorate, a perchlorate. There's also chloride. So this is chlorite, ClO2, 1 minus. Okay, so I have ClO2, 1 minus. All right, so when you look at the charges, you have a 2 and a 1, so they don't cancel. I don't crisscross this 1. All right, this 1 stays exactly where it is. All right, so I'm going to crisscross this 2. But chlorite is a polyatomic ion. So we said that polys get parentheses. So chlorite goes in parentheses. What got crisscrossed goes outside. All right. Let's try, we have a couple more examples on like special cases that I want to go over. So in this one, example 3, let's do aluminum carbonate. All right, so we have aluminum carbonate. Pause the video if you want to try it on your own. Aluminum is Al, it's in group 13, so it has 3. Carbonate, I'm going to look at my chart, and carbonate is right here, CO3, 2 minus. CO3, 2 minus. Now what you notice with this is, one, they don't cancel, but there aren't any 1s. So I have to do a double crisscross. So I cross the 2 down here, and I cross the 3 down here. So Al2, polys get parentheses, CO3 is carbonate, and this 3 goes on the outside of the parentheses. So you can have a double crisscross. Let's do example 4. Let's do iron 3 cyanide. Now here's a special case. If you want to try this on your own, go ahead. If you want to follow along with me, that's absolutely fine. All right, so first I write my cation. So I have iron, I have Fe. What's its charge? The Roman numeral. Cyanide, there's no element on the periodic table that is cyanide. So I get to my chart. Maybe you kind of remember where some of these are. Cyanide is right there. Cn minus. So it's Cn, whoops. I read my lesson the other day. I can't annotate with this and scroll the screen. Cn minus. All right, so try to get the answer on your own. There are two answers that kids usually get in class. And the two answers that I usually see in class are this. The most common answer, they're like, oh, Chris cross. FeCN3. This is the most common wrong answer. Why is this wrong? Well, the 3 is next to the nitrogen. So essentially you're telling me I'm taking nitrogen 3 times. But we don't want to take nitrogen 3 times. We want to take cyanide 3 times. And cyanide is a polyatomic ion. The difference between cyanide and the other examples is that there's no number down here. So it's still a polyatomic ion, so it has to go in parentheses because you want to indicate to someone, I'm not just taking the N 3 times, I want to take this whole thing 3 times. So that's a special case. There are only 2 polys that, I think there are only 2 polys on this chart that don't have a subscript. Those 2 polys are cyanide and hydroxide. They still get parentheses when you crisscross. Okay? All right. Let's see if I have time for one more example of this video. One more quick one. Okay. So our last one, let's do example 5. Let's do ammonium phosphate. This is kind of tricky. All right, so pause the video if you want to try it on your own. If not, follow along with me. All right, ammonium. Everyone has such a difficult time trying to find ammonia. Ammonia is the only positive cation. It's NH4 1 plus. So ammonium is NH4 1 plus. Phosphate. Maybe you remember some of these charges. Phosphate is right here. PO4 3 minus. Okay, so phosphate is PO4 3 minus. Okay, maybe you had trouble finding this. Pause it if you want to get the answer on your own. If not, follow along. All right, so we have phosphate and ammonium. I'm not going to cross this 1. However, I need to cross this 3, and it needs to go here. Is ammonia a polyatomic ion? Yeah. Are we going to put it in parentheses? Yes. Am I going to cross that 1 down there? No. Ammonia is the only polyatomic ion that is going to get parentheses in the beginning. So don't let this be difficult. Crisscross. If you're crossing to something on that chart, put it in parentheses.